In this section, we're going to look at how to solve differential equations that fall into the separable category. So we're going to define what a separable differential equation is. We're going to solve both differential equations to get the general solution, and then also solve initial value problems to get the particular solution. A separable differential equation is exactly what it sounds like. We can separate it so that we get all the terms and differentials with respect to x and y on one side of the equation, and then we just integrate both sides. All right, so basically, if we have a function f of x, y, all right, so a function that's composed of both x and y variables, then what we can do is we could just separate this so that way we get phi of xy dy on one side and g of x dx on the other side. All right, so the goal is to basically get all of the independent variables to one side and all the dependent variables to the other side. And then what we can do is we can integrate both sides, because at that point, we would just go through and get rid of those differential operators dy dx. All right, so let's take a look at a number of examples to where we can go through and not only just solve a separable differential, but also kind of see what it looks like to be able to on a graph. All right, and we'll just do that with the first one, so we can kind of go back to the big picture of the slope field and the particular solution. So we have a fairly basic sort of initial value problem here. So we have t to the minus fourth, y prime at t equals y, y at 1 is equal to 3. And we want to find the general and particular solutions, and we want to solve it as a function of the independent variable. We want to plot the direction field, and then finally, we want to plot the particular solution on that direction field. All right, so first thing you want to do is whenever you have y prime at t, you're just going to change that into dy dt. All right, so that way we can just prepare it to be able to be separate. So t to the minus 4 dy dt. All right, so we have our independent variable and our dependent variable y in the numerator. All right, and then that's equal to y. Now what we're going to do is we're going to solve this so that we get all the y's to one side and all the x's to the other. So since this is the first time we're doing it, let's do this fairly incrementally. All right, so I'm going to start by dividing both sides by y. All right, so I get t to the minus fourth dy divided by y dt is equal to 1. Then I'm going to multiply by dt. So this is going to give us t to the minus fourth dy over y equals dt. And then finally, we can multiply both sides or divide both sides by t to the minus 4. And so this is going to yield two things, okay, or one of two things. So we're going to have dy over y equals dt over t to the minus 4, which is really the same as dy over y equals dt or t to the fourth dt. All right, since that's a negative in the denominator. All right, so now we have a separable differential at this point. All right, so now that we have a separable differential, now what we're going to do is we're going to integrate both sides, and both of the integrals are really easy to evaluate. So we know that dy over y is going to be natural log of y, and then the antiderivative of t to the fourth is 1/5 t to the fifth plus a constant of integration c. Now, to be able to solve this for the independent variable, okay, or as a function of the independent variable, we have to basically solve it for y, which essentially means we're going to write this as y equals e to the 1/5 t to the fifth plus c. Right? Now, a trick, especially for those of you that are going to take differential equations, is that we can rewrite this as y equals e to the 1/5 t to the fifth times e to the c, and e is a constant and c is a constant. So we can finally write this as y equals ke to the 1/5 t to the fifth, where k is the same as e to the c. All right, so that's probably going to be the most simplistic general solution that we can get. Okay, so this is for part A. Now for part B, we have to find the particular solution, which means that we are just going to substitute t equals 1 and y equals 3, given that initial value. All right, so we have 3 is going to be equal to ke. Right, so again, we're just substituting when t equals 1, y equals 3. So 1/5, 1 to the fifth. And so this is going to be 3 equals ke to the 1/5. Right? And to solve for k, we're just going to divide by e to the 1/5 power. So this is going to be 3 over e to the 1/5 equals k, or another way to write that is 3 over the 5th root of e, right? And so that means that the particular solution for this is going to be y equals 3 over the 5th root of e, e to the 1/5 t to the 5th. All right, so that's as good as we can get to be able to get our particular solution for this. All right, now for part C, we just need to plot the slope field. All right, to be able to plot the slope field, we're just going to solve this for y prime. All right, so for part C, remember that we had t to the -4, y prime of t equals y. And so we could just divide both sides. So we have y prime equals y over t to the -4, which is really the same as saying y prime equals t to the 4th y. All right. And this is what we're going to plot in our Desmos. Okay. So you have to go back to the previous section. We have the link to be able to get the Desmos. Okay. So I'm just going to go over here. I'm going to plot my function. Now I'm just going to change the x to a t. And remember, our function was y times t to the 4th power. All right, so this is our field. And then down here, what we're going to do, so this is the slope field. So that's part C. All right, if you look back at our instructions, it says to be able to plot the direction field or the slope field for this. And then finally, we're going to plot the particular solution on the direction field. And the particular solution was 3 over 5th root of e to the 1/5 t to the 5th. All right, so we're just going to plot this function on that slope field. And doing so, that's going to be 3 divided by exp. Well, we could say quantity exp of 1. And then we're going to raise that to the 1/5 power to be able to put it in there. All right. And then that's going to be times exp of t, or 1/5 t to the 5th. And we're going to have y equals. All right. And there it goes. Okay, so it just plots right in here. It looks like it plots really nicely on this curve. Okay, you can see that it's following all these sorts of all the trend lines. Okay, notice on the axis it is flat. All right, so it says it's vertical, except when t is equal to 0, right? Because if you look at the original differential, when t is 0, the slope is 0 as well, regardless of the value of y. All right, so just be careful if you're checking your answer and you're dragging this thing along. It says that everything's vertical pretty much, except when you get to that x-axis. Okay, so you can see like right here that just t is going to be 0 for this. But every other time, it looks like it's conforming. Okay, especially like right here, it conforms perfectly, and then right here it conforms perfectly to the curve. And that's what you want to do. Is if you ever want to check your answer, aside from finding the multiple derivatives and substituting back in, you could just look at the function on the slope field. All right, so in the next videos, we're just going to look at other sorts of separable differentials and how we're going to solve those.